All right. So, hello and welcome everyone. We are live right now. I hope I'm audible to all of you. Just do let me know if I'm audible or not. Yes. So, yeah, we are live and audible as well, right? Okay. So, welcome back. Welcome back to this amazing platform of Tutee Learning. So, today we're going to continue with our previous discussion that we started on the topic of circles, right? So, if you are someone who is new to this particular platform, let me tell you about this platform. This particular platform or the Tutee JEE channel is basically focused on covering those particular contents, especially in maths, physics, and chemistry, which are going to be very relevant for your upcoming engineering examinations, right? So, be it NEET examination, be it JEE examination, or any other competitive state board examination, right? Which is basically based out of the syllabus of 10+2 level, where the NCERT syllabus is mostly followed, then this particular channel is going to help you a lot in understanding the basic concepts, right? So through this particular lecture, we will take this particular opportunity to discuss about the basic topics on questions of coordinate geometry, right? So as we have already covered the straight lines, and now it is our role or our task to basically start with our new chapter, that is circles, right? So in the previous lecture, we have already started to discuss about the basic concepts regarding the circles, right? So as of the today's class, we are also going to discuss about the solving problems on the different types of questions. Okay, and along with that, we are also going to look into some of the deep dive properties regarding circles, right? So that will be the entire motto for today's discussion, and also we'll be indulge ourselves with solving questions only, right? So if you recall that in the last class I asked you to solve and find out a generalized expression for the equation of circle passing through these 3 points, right? So how you must have achieved this particular thing is that, first of all, we know that the general equation of circle can be written something like this, right, which is equals to 0. Now if I have 3 points, now if I look for the number of unknowns in this particular equations, I will see that here there is G is unknown, F is unknown, and C is unknown, right? So three unknown, so must be three condition to solve this particular equation, right? And that three condition will be obtained by placing these points A and B in this equation of the circle, right? And then solving for the with the given points to equal to 0, we can find out the value of the required constants G, F, and C, right? So that is what we will be doing to get to this final expression, right? So I must hope that you must have tried to solve this problem and you must have got a generalized result for this constant G, F, and C, right? So I'm leaving that particular part up to you for to get to the derivation, right? So please do it by yourself, okay? And you can see that this is three equations and three unknowns, right? So three equations with three knowns as well, that is x3 y3 x2 y2 and x1 y1 are the three conditions given to us, and you will have a three sets of equation which you can easily solve by using the determinant rule, right? So you must be solving the determinant to basically get to the solutions, right? So that is what I leave up to you, because you will get a linear equations, right? So solution of three linear equation is already known to all of us, right? So from our previous discussion on matrix and indeterminate, right? So please try to apply that particular part over here, and then you try to solve this problem, okay? So let us now move forward towards discussing, or let us go on towards solving some of the questions in this class, right? Okay, so here is the question that I am going to take up. So this is a simple problem and yet an basic and question which is very relevant, especially if you are starting to solve problems on circles, right? So this is another interesting problem that we need to solve. So the question talks about that you have to find the equation of the circle which passes through these 2 points, right? It passes through this 2 point, and the center of that particular circle will lie on this particular line. Okay, the center of the circle will lie on this particular line. All right, so how do we solve this question? Okay, so before I go on to discuss the solution, I would like all of you to participate and let me know how would you like to solve this particular problem. Okay, just do let me know how would you like to solve this problem, and then I will go on explaining what are the steps that you need to take in order to come to the final answer. Okay, so please give it a try. Okay, please do give a try, and then we'll go on discussing about how we can solve this, right? All right, so I hope you have all tried or read through the problem. So let us first of all assume or try to solve this problem by assuming the general equation of the circle, right? So if I assume the general equation of circle, which is basically x square plus y square plus 2 times of gx plus f 2 times of fy plus some c is equal to 0, right? Now for this given circle, two important things are very relevant, right? That is, from this general equation of circle, I can say the center of the circle. Let us get the center of the circle, that will be minus g comma minus f, right? The center of the circle will be minus g comma minus f, right? Now if you recall in the question, it is mentioned that this particular center lies on the line 3x plus 4y equals to 7. This particular center lies on this particular line, right? So if I solve for this, then I will get to the relation, that is 3g plus 4f is equals to minus of 7, and that I will get as one equation, right? Similarly, the other two equation can be easily formulated by placing this particular point 1 comma minus 2 and 4 comma minus 3, right? So from there I will obtain two more equations, and those are as follows: 5 plus 2g minus 7f plus c equals to 0. This is another equation, so let us call this equation number 2. Okay, and another equation will be 25 plus 8g minus 6f plus of c is equals to 0. This is my third equation. So you can see over here that we obtained three linear equation or three sets of linear equation, right, which you can easily solve for to obtain the three unknowns, right? So please try to solve these three sets of linear equations. Okay, please try to solve these three sets of linear equation which you have already studied by something called as the Cramer's rule, right? So please try to apply that and find out that what will be the required values of g, f and c, and from there we can formulate for the equation of the circle. Okay, so please try to solve it and let me know what is the answer you are getting. Please solve this and let me know the answer you are getting. Please try to solve this and tell me the answer. Okay, try to solve it and tell me the answer. Okay, so if you solve this, then you will get to the value of g and f as follows. So if you try to solve it, you will get to the values of g and f. So maybe you can check. Okay, so I got the value of g as 47 upon minus of 47 upon 15, the value of f as 3 upon 5, and the value of c as 11 upon 3. Okay, so these are the three values of the unknowns which I obtained by solving for the three linear equations, right? So from here I can say that the equation of circle will be equal to 15x square plus 15y square minus 94x plus 18y plus 55 is equals to 0. So this is the final answer for the equation of the circle. Okay, I hope this question is clear. Okay, so let us now move towards understanding another important concept, that is regarding the equation of circle with a given diameter. So what happens if I know the diameter of the circle? Okay, so that is what I am going to discuss. So equation of a circle with a given diameter. Okay, so what is the equation of circle with a given diameter? So that is what is my next motto to discuss, right? So let us say, what does this problem mean? In order to formulate for this problem, uh, let us try to explain you by a schematic diagram. So we have the circle over here, okay, and to give you the results, let us say that we know the diameter, okay, we know the 2 points on the diameter, that is, let us say x1 y1 and x2 y2 are the two opposite points on the diameter of the circle, right? And the circle, let us say the center of the circle is some h comma k. Okay, so we know this particular thing, right? Now we have already studied one of the very important property that any point on the circle will subtend 90-degree angle at the diameter, right? So if I take up any point, let us say P, which is given as x comma y, then if I take this point P and if I try to see what is the angle this point P is subtending on this diameter, this particular angle is going to come out as 90 degree, right? This is one of the very crucial property regarding the circle, right? So if we try to apply to this property, and we will try to find out that how this x comma y can be related with this particular known values of x1 y1 and x2 y2, which are nothing but they are the diametrically opposite points of the given circle with the center as C, right? So how can we solve this problem? So in order to solve this problem, we are going to utilize the concept of angle between two lines. So what you can see that the angle between this line AP and PB is 90 degrees. So from here, if I take the product of the slope, that should be equal to minus of 1, right? So the product of slope, that is AP, the slope is m1, and PB, the slope is m2. So the product of the slope m1 m2 should be equals to minus of 1, right? Now if I find out a slope for AP, it will come out to be, so if you recall the slope of AP, so that will come out to be y minus y1 divided by x minus x1 multiplied with y minus y2 divided by x minus x2, and this result should come out to be minus of 1, right? And this particular result should come out to be minus of 1. Okay, this particular result should come out to be minus of 1 because they are perpendicular lines, right? So if I apply that, then from here only I am able to get to the final condition, that is y minus y1 multiplied with and then add with x minus x1 multiplied with x minus x2. So this particular sum should come out to be 0. So this is what is called as the general equation of the circle whose diametrically opposite points are given as x1 y1 and x2 y2, right? So this is my required equation. So from here I can do the simple two steps which I have avoided over here, which I have skipped over here. So you can do these two steps of calculation to get to this final algebra, right? I hope this is clear to all of you. I hope this discussion is clear. Is this part clear? Do let me know if you have any questions, any queries. Okay, do let me know if you have any questions. Okay, do let me know if you have any questions. Okay, so this is how we get to the required equation. Okay, I assume this is clear to all of you. So if this particular form of the equation of circle is clear with the diametrically opposite points given to us, now we can try to move towards understanding some other important properties and also move on to solve some important questions. Okay, so let us first of all try to take one problem in this particular regard, right? So this problem is again relating to the previous properties or geometrical properties regarding circles, right, and tangents. We haven't discussed tangents so far, but I know you have already studied tangents in your junior classes, right? So with that particular idea of the geometrical properties of tangent, we'll try to solve this problem. Okay, so the question given over here is that you can see the question mentions that the tangent PA and PB are drawn to the circle, drawn to this particular circle from a given point x1 y1 which is lying outside the circle. If you have this particular formulation of the problem, you have to find out what is the equation of the circumcircle inscribing the triangle PAB. So let us try to understand what the question means. So if you look at this particular equation of circle, that is x square plus y square is equals to a square. This is nothing but a equation of circle with a center as 0 comma 0 and the radius is equals to a, right? So if I try to draw that, so let us say this is my circle with a center at 0 comma 0 and the radius is point value as a, right? and let us say these are the point A and these are point B. Now let us say this is point P, which is x1 y1. From this point P, two tangents are drawn to the circle. Okay, from this point P, two tangents are drawn to the circle like this. So by again let us construct the geometry. We know that the radius and the tangent intersect at a perpendicular, make a perpendicular angle, right? So we have to find out the circumcenter considering PAB as the triangle. Okay, so if I try to draw that circumcircle, it will be something like this, and we'll see soon in our properties that the circumcircle of this particular case always pass through this center of this particular circle. Okay, we'll see this particular property to hold true, right? So if I have this following plot of my problem, now I can easily solve, because I know by property that since C will also pass through a circle, and another very interesting property is that this PC will become the diameter. PC is the diameter. Why? Because this particular angle is 90 degrees. So any point of the circle will make a 90-degree angle or subtend an angle of pi by 2 at the diameter. So therefore from here I can say that PC is basically going to be my diameter. So if I know the diameter, if I know the vertically opposite or diametrically opposite points of the circles, then I can easily formulate for the equation of this circumcircle. So the equation of the circumcircle, okay, the equation of the circumcircle of this triangle PAB, that is going to be x minus x1 into x minus 0 plus y minus 0 into y minus y1, and that should be equal to 0. So if I just simplify this result, this should come out as x square plus y square plus minus of x1 minus of y1, and that should be equal to 0, right? So also one more interesting observation over here is that whenever a circle pass through origin, the constant is 0, right? That's part of C is equals to 0, right? So it is a general observation that you can always see, right? If the circle will pass through origin, that is 0 comma 0, then C should be equal to 0. Okay, I hope this is clear to all of you. I hope this is clear. Is this part clear? Please do let me know if this part is clear or not. Okay, because this is very important and we need to understand this all basic concepts before we go on to solve some important JEE Mains previous year question. Okay, so by knowing these all properties, it will help you to quickly solve the questions, especially in your competitive examinations. Okay, so that's why it is very important to have a note on this kinds of formulation of this problem. Okay, so let us now, with this particular understanding, we are now ready to move on to learning about another important form of the equation of circle, that is called as the parametric form. Okay, that is called as a parametric form of the equation of circle. Okay, so let us try to see what is the parametric form. Okay, so let us try to understand what is the parametric form of the equation of circle. Okay, so let us try to see the parametric form of the equation of the circle. Okay, so let us try to see the parametric form for the given equation of a circle, right? So in order to describe this parametric form, two things should be known to you, that is, one is the radius and another is the center of the circle, right? So let us try to draw the coordinate frames, the coordinate axis. Let us say we have a circle with some center h comma k. Okay, let us say we have a circle with some center as h comma k, and the radius of the circle is given as r. Okay, this is our given problem. Okay, this is our given problem, right? Now the parametric things means that the two unknowns or the two things x and y can be expressed in terms of one particular variable, that can be either theta or any variable, right? That is what is called as parametric form, right? So what do we actually mean by parameter over here, that we will try to relate with this particular equation, right? So let us try to see that how I can relate to this parametric equation of circle, right? So in order to do that, if I consider So let us say this is my equation of, this is a circle and with a center as h comma k. Let us say this is my x-axis direction and this is the direction of my y-axis. Okay, now if I take up any point lying on the circle, let us call that any point as x comma k, what I can also write is that it is obtaining some angle theta with respect to the x-axis, right? Theta with respect to this x-axis. So once I know this theta and also I know what is this r, right? This particular distance, that is the radius, is also known to me, right? So now if we want to write down the equation of circle, we can write it as x minus hs whole square plus y minus k whole square should be equals to r square. That is my general equation of circle with the given center as h comma k. Now what I'm going to do is over here is that I'm going to try to represent this particular form by breaking into a right angle triangle over here, right? So if I express this right angle triangle over here, I can represent this x and this y in terms of this trigonometric function sine theta and cosine theta, right? So let us try to do that. So in order to do that, well, if we do that, uh, from this right angle triangle, I will get x minus h to be r times of cosine of theta and y minus k to be r times of sine of theta. So from here I will get x as this known value h plus r, which is also known to me, and times cosine theta. So this is what is called as a parameter, right? So here the theta is a parameter, and by varying theta I am going to get different points on this particular circle, right? So what I can obtain is some sort of relation like this. So here my theta is the parameter, right? Here my theta is the parameter. Here my theta is a parameter. So by varying this theta parameter, which can lie between 0 to 2 pi, so by varying this theta from 0 to 2 pi, I'm going to obtain all the points on the circle. I hope this discussion is clear. So this is also called as the parametric form of the required circle. Okay. I hope this is clear to all of you. I hope this is clear. So let us quickly try to look into one simple problem if we understood this particular result. So here the question says that if I give you a parametric equation of a circle like this, can you find out what is the center of the circle? Okay, so this is a very straightforward problem. So please try to solve it. Okay, so please solve it and let me know the answer. Please quickly solve this problem and tell me the answer. So quickly solve this problem. Oh, sorry, I made a mistake over here. It should be k, right? It should be k over here. This is h plus k. Y is equal to k plus r sine theta. Okay, yeah, just a small modification. It should be k. All right. So over here, if I have this equation of circle like the given in the parametric form, so from here what I can do and can write x plus 1 is equals to 2 times of cosine theta and y minus 3 equals to 2 times of sine theta. Now in order to remove this sine theta and cosine theta, if I just take these two equations square and add it, then I will get the following equation as x plus 1 whole square plus y minus 3 whole square is equals to 4. Now this is free of this parameter theta, and this is our general formulation of the circle, that is where the center is minus 1 comma 3 and my radius is 2. Okay, so these are the following value that I can easily obtain once I know the parametric form of a circle equation. Is this clear to all of you? Is this part clear? Is this part clear? Do let me know if this is clear or not. Okay, so if this is clear, let us now move towards understanding another set of important parameters considering the circles, that is called as intercept made by the circle on any axis, right? So let us now learn about intercepts, okay, that is made by the circle. Okay, the intercepts made by the circle. Okay, so let us try to understand about this particular concept and how do we find out the length of the intercept with the given general form of the equation of circle. Okay, so let us try to draw a circle over here such that it has some intercept with the x and the y axis, something like this. Well, let us say this is my center, which is given as, so the center of the circle is given as minus g comma minus a from the standard or general equation of the circle, that is x square plus y square plus 2 times of gx plus 2 times of fy plus some constant equal to 0, right? This is my general equation of the circle, right? This is the general equation of the circle. Okay, so from this general equation of the circle, I can find out two of the important parameters, that is my x-intercept and the y-intercept, right? Now, first of all, let us try to understand what do we actually mean by x-intercept and the y-intercept, right? So for any general curve, the point where the curve is intersecting on the x-axis, that particular point distance is basically called as the x-intercept. Similarly, the point where the curve is intersecting on the y-axis, and if I take the distance of that, then that is called as my y-intercept, right? So this is my x and the y-intercept, which I have represented by these white arrows, right? But how do we actually find out the value of this intercept, right? So in order to find out the value of my intercept, what I can do, I can simply use the concept of the triangles over here, right? So what I can do, if I take a simplified case, let us say I take a simplified case and I want to find out the intercept, right? Let us drop a perpendicular over here and try to form these two triangles. I know this distance to be r, or the radius, right? These are my distances as the radius, and also this is my center, which is given as minus g comma minus f. So, and I know this is my x-axis, so this particular distance should be minus of f. So from here I can easily find out this particular distance, and multiplying by twice I will easily get this whole distance, right? So that is what my plan, right? So if I do that algebra and I carry it out, so you will see that finally you will be able to get to the final result, that is the value of the length of the x-intercept will turn out to be 2 times of square root of g square minus of c, okay, 2 times of square root of g square minus c, and the y-intercept, will become 2 times of square root of f square minus c. Okay, so these are the two important results that you will obtain if you carry out this following algebra. The algebra is very simple from here. So if you just apply the concept of Pythagoras theorem and you try to find out this particular length, which I am leaving up to you, and if you find out these distances, it will come out to be something like this. Is this clear to all of you? Dhruv, hello Dhruv, you are late in joining the class. Okay, are you new to this particular platform? Hello Dhruv, are you new? Okay, so I hope this is clear. So now we can proceed towards solving some problems, right? Now we can try to solve some problems in order to understand these all concepts in a better manner, right? So the question says that this is a very interesting way of asking us the same things over here that we have discussed, right? So let's try to read through the problem. So if you read the problem, the question says that if the intercept of the variable circle, okay, if the intercepts of a variable circle on the x and the y axis are given as 2 units and 4 units respectively, then have to find out the locus of the center of the variable circle. Wonderful question, right? So in order to understand this, let us try to understand the concept of locus, right? So we have already discussed the concept of locus, but for new viewers, I would like to repeat it again. The locus is basically a set of variable point that is following some mathematical condition, as straightforward as that, right? So if I consider the center of the circle to be minus g comma minus f, and if I try to represent this g and f by some mathematical relation which is free of other variables except g and f, and then once I get the mathematical relation in g and f which is void of, or which is not containing any other constants or any other variable, then that particular mathematical equation is called the locus of that particular curve, where I just replace this g minus f with x and y, right? So that will be the understanding, right? So over here, if I consider this my center as minus g comma minus f, and we have already studied the intercept, x intercept to be g square minus c square root of that multiplied 2, and that is equals to 2, and similarly 2 times of f square minus c, and that is equals to 4, right? So from here I can relate one equation consisting of like f square minus c will be equals to 2 square, which is again equal to 4, and similarly g square minus c would be equal to 1. So what I can relate is that this 4 can be written as 4 into 1, and therefore I can relate this f square, or maybe what I can do is that from these two equation, let us call this first equation and let us call the second equation, if I just subtract it, I am going to get rid of this unknown c, right? So if I just subtract it, then I will get the form of the equation f square minus g square will come out to be 3, right? So this is a mathematical equation consisting of f and g, which is devoid of any other variables, right? So therefore the final locus equation, okay, so the equation of the locus is now I will obtain by just replacing f and g with x and y, and that should come out to be y square minus x square is equals to 3. So that is my final result for the given locus. I hope this is clear to all of you. I hope this question is clear to all of you. Okay, is this part clear? Right. So with this, we have discussed quite a lot of important things in today's session, where we have seen that how we can get to the intersect form of the circles, and also we have learnt about how to formulate the equation of circle whose diametrically opposite points are given, and also we learnt about another very important concept, that is the parametric form of the equation of the circles, right? ध्रुव हिंदी, अच्छा ठीक है, मैं हिंदी में बोलने की कोशिश करूंगा, ठीक है? ओके ध्रुव. So with this part, we come to the conclusion that of the basic forms of the circles, and now onwards what we're going to discuss is that we're going to take up some of the few more cases of different forms of circle equations, right? And from there we're going to solve some more important questions, right? And then we are going to soon move towards understanding the miscellaneous topics, that is the concept of position of a point and a circle, or the tangents, the normals, and the following concepts, right? So we will soon build upon the other theories on this particular chapter of the circles, right? So if you just recall that we have been I have showed you the basics, that what we need to study in this circle. So these are all the concepts. So we have already discussed about the definitions and the different forms of the equation of circle. So in the next class, we're going to start with positions of a point with respect to circle, right? And then we're going to soon move with this particular topics, right? So I'm going to follow exactly this particular syllabus over here, okay, this particular order of finishing the topics of this chapter of circle. I hope this is clear, and with this I conclude the session over here. Thank you, and I hope to see you soon in our next class, right? So in the next class, we're going to quick start with the position of a point with respect to line, and then we're going to move into line and a circle, right? So I hope you have enjoyed watching this particular lecture and you have learned something new in today's class. बोल्ड इंसान, मेरे को सर्कल में एक डाउट है, बताओ बोल्ड इंसान. See, for asking doubts, you have to be regular in the lecture and start to be present in the lecture from the beginning, right? Okay, so please ask your doubt. Okay, and if you're new to this particular platform, please subscribe and also share these videos with your friends, your family members, or maybe your relatives who are preparing for the JEE examination, right? ध्रुव पूछ रहा है कि टिप्स बता दो JEE 2026 के लिए. देखो ध्रुव, टिप्स फॉर JEE 2026 इज बेसिकली वेरी सिंपल. जो मैं पढ़ा रहा हूँ अभी इस क्लासेस में, उनको ढंग से फॉलो कर लो, ठीक है। और मैथ्स के लिए मैंने ऑलरेडी एक ऐसे लेक्चर्स बना दिए है जो बेसिकली हाई प्रायोरिटी वाला चैप्टर्स है ना, जैसे कि कैलकुलस हो गया, जैसे वेक्टर्स एंड 3D ज्योमेट्री हो गया, और अभी में हम करा रहे ये कोऑर्डिनेट ज्योमेट्री, राइट। तो ये बेसिकली वो टॉपिक्स है जो आप हाई स्कोरिंग टॉपिक्स है और उसको समझने में ज्यादा दिक्कत भी नहीं आता। तो पहले ये वाला चैप्टर्स खत्म कर लो, फिर you move on to discussing about the other chapter, right? So, or one more thing, we are going to start with one short revision session for JEE Mains, one short revision session for JEE Mains from November, okay, 26th, okay. So from 26th of November, we are going to start with our revision, okay. So अगर आप JEE Main पहला attempt के लिए थोड़ा nervous ho, so please attend this revision sessions, okay. And through this revision session, this will be one shot, okay. We'll try to recollect all the concepts in the chapter, okay. So through this one shot lectures, we will recollect all the concepts in the chapter, and with that we'll get with our JEE Mains preparation, right? प्रैक्टिस सेशन चैप्टर वाइज डेफिनेटली ध्रुव प्रैक्टिस सेशन आने वाला है, यहाँ पे ही आने वाला है, ठीक है। जब मैं चैप्टर वाइज रिवीजन कराऊंगा ना, उसके साथ साथ मैं प्रीवियस ईयर क्वेश्चंस का प्रैक्टिस भी कराऊंगा, ठीक है। बस आप चैनल को सब्सक्राइब कर लो और डेली फोकस करके पढ़ते रहो, ठीक है। जो भी चीजें मैं यहाँ पे पढ़ा रहा हूँ, बस उसको डेली फॉलो कर लो, ठीक है। बस सब्सक्राइब कर लो और फॉलो कर लो, और एक बार बेल आइकन को भी क्लिक करके रख दो, ताकि जब भी नोटिफिकेशन आ जाए ना, तब तुम्हें डायरेक्ट तुम इस क्लासेस को अटेंड कर सकते हो, मतलब लाइव, ठीक है। और तुम्हारा जो भी डाउट्स है तुम मुझे लाइव में पूछ भी सकते हो, राइट। बोल्ड इंसान का डाउट है, फैमिली ऑफ सर्कल में डाउट है, तो फैमिली ऑफ सर्कल्स में डाउट है। देखो बोल्ड इंसान, आई एम डेफिनेटली गोइंग टू कवर फैमिली ऑफ सर्कल्स, ठीक है, डोंट वरी। अभी अभी हम बेसिक कवर करें, राइट, जहाँ पे हम देख रहे हैं कि डिफरेंट फॉर्म ऑफ द इक्वेशन ऑफ सर्कल कैसे लिखते हैं, राइट। सो जैसे जैसे चैप्टर में आगे बढ़ेंगे, वैसे हम फैमिली ऑफ सर्कल्स को भी कवर करेंगे, राइट। जैसे फैमिली ऑफ लाइन्स में L1 इज इक्वल टू लैम्डा 2 लैम्डा L2, नहीं देखो, फैमिली ऑफ लाइन्स में कॉन्सेप्ट क्या था कि हम दो लाइन का इक्वेशन जानते हैं, तो मेन क्राइटेरिया क्या था, मान लो उस दो लाइन के इंटरसेक्शन से अगर कोई भी लाइन बनाना हो, तो हम उसको लिख सकते हैं L1 प्लस लैम्डा टाइम्स ऑफ L2, राइट। ये कॉन्सेप्ट था, ठीक है। दैट वाज L एंड दैट शुड बी इक्वल टू 0, सो दिस वाज द इक्वेशन ऑफ दैट फैमिली ऑफ द लाइन्स, राइट। इन द सिमिलर मैनर सर्कल का भी फैमिली ऑफ सर्कल हम ऐसे भी लिख सकते हैं, राइट। दैट इज लेट अस से S1, हम आगे जाके सीखेंगे कि S1 लिखते सर्कल का इक्वेशन को S1 प्लस लैम्डा टाइम्स ऑफ S2 इज ऑल्सो इक्वल्स टू 0, राइट। तो इसको कहते हैं हम फैमिली ऑफ सर्कल, राइट। बट ये काफी जल्दी हो जा रहा है, ठीक है। हम पहले सीखते हैं कि S क्या होता है एंड हाउ ऑल द डिफरेंट फॉर्म्स ऑफ द फैमिली ऑफ सर्कल, ठीक है। सिर्फ S भी नहीं होता, यहाँ पे L भी यूज कर सकते हैं, यहाँ पे डिफरेंट फॉर्म्स भी यूज कर सकते हैं, ओके। सो फॉर दैट प्लीज हैव अ पेशेंस, वॉच द लेक्चर टिल द एंड, ठीक है। हम ये सब कवर करने वाले हैं, ठीक है। आप एक बार धीरे धीरे जो डेफिनेशन वाइज हम बिल्ड कर रहे हैं ना, उसको फॉलो करो, ठीक है। एक बार फॉलो करो, क्लासेस जैसे आगे बढ़ते जाएगा तुम फैमिली ऑफ सर्कल भी सीख जाओगे, ठीक है। हाँ, मैं ये ही कह रहा था, डेफिनेटली सीख जाओगे, ठीक है। सो थैंक यू, एंड विद दिस आई कंक्लूड द सेशन ओवर हियर, एंड आई विश यू ऑल द बेस्ट एंड होप टू सी यू सून इन आवर